Okay, so this is going to be our mass to mole and mole to mass island video. So hopefully this will get you some help with that one. We do still have that leader island thing that's kind of floating out there. I don't know if we're going to get to that tonight, but if I don't tonight, get that video up, I will get it to you tomorrow. Or we will maybe just not have one of those problems on the exam. We'll see what happens. Okay, so first of all, we have this molecule, Na2SO4, and we also have all of the masses written out, so that might tell you something. If you've seen the first two videos that I made, which are the percent composition one and the molecule or FU island one. So those two, I talked a little bit about having these numbers here, but it basically means that we are going to be calculating the molar mass. Start off, this is sodium sulfate with an A, because it's SO4 instead of SO3. And sodium sulfate, we can calculate the molar mass, but we want to get the mass of this molecule if there are 3.078 moles of it. So we're given moles, that means we are on Mole Island, and we are wanting mass, which means we want to go to Mass Island. So to first do this, we need to come up with a molar mass. So there are two sodiums in this molecule, and each sodium weighs at 22.99 grams. And we have one sulfur, so I will add 1 times the molar mass of sulfur, 32.06. And to that, I will add 4 times the mass of oxygen, or 16.00. Again, this is a polyatomic ion, but there is no number down here like a 4 or something. Because this 4 is inside the parentheses and right next to the oxygen, it means that there are 4 oxygens and not something like SO4. So SO4 would be S4O4, and that is not sulfate. Sulfate is SO4. Right, so if we write this as our polyatomic and we put our parentheses around it like we usually do, this is what it looks like. And so there are 4 oxygens and 1 sulfur, not 4 oxygen or 4 sulfur. So if I take these numbers, these masses, I forgot my grams on that one, and this also grams. So we have our 2 times 22.9 grams for our sodium. We have 1 times 32.06 grams for our for our sulfur. We have 4 times 16 grams for our oxygen. And the total molar mass I calculate is 142.04. And this is a molar mass, and so molar, moles, and mass, grams. So this is saying that we have 142.04 grams for every mole of this Na2SO4 substance. So we are again on Mole Island, and we want to go to Mass Island. That tells us that we need to have our, actually, let's just start off by writing out our number of moles, 3.078 moles. And we do our boat thing, and so what we put below deck is the island that we are currently on, because we don't need that stuff anymore. We're leaving Mole Island, and we are going to Mass Island. So the thing that goes down below on Mole Island is 1 mole. And the thing that goes up above to get us to Mass Island is the molar mass, 142.04 grams. So again, this is saying that 142.04 grams is equal to 1 mole, or 142.04 grams is 1 mole. We take this and we multiply it by 3.078 moles, which should give us this number of 437.20 grams. So there's no Avogadro's number, but there is still masses and molar mass. Those are both important for this. But all it was one step. We went from moles to grams just like this. Next one says, what is the mass of 1.29 moles of C6H6? That's benzene. It's a cyclical hydrocarbon. It's actually a really cool thing. And basically, you have 1 carbon, 2, 3, 4, 5, 6 carbons, and they are bonded and double bonded to each other. And then there's also a hydrogen sticking off of each of these carbons. It's a really super important molecule. I mean, so much of our chemistry in terms of like making plastics and all kinds of medicine, stuff like that, it really depends on benzene. But all right, we need to calculate the mass of this 1.29 moles of our benzene. And to do that, we need to find our molar mass of benzene. So there are 6 carbons and there are 6 hydrogens. And so what we do to calculate our molar mass is take the number of carbons times the mass of each carbon, 12.01 grams. And we add the number of hydrogens times the mass of hydrogen, 1.01 grams. And the answer that I will get from that is 78.12 grams per mole. And again, this is saying there are 78.12 grams per every mole of this stuff. Or another way of saying it is 1 mole of this stuff, this benzene stuff, will weigh 78.12 grams. I can write this in either way, and it means basically the same thing, that it will allow me to go between gram or mass island and mole island. Depending on the direction is how we, whether grams is on top or on bottom, really depends on the direction that we're going between mass and mole island. Okay, so we know our molecular mass, and the next thing that we need to do is go from moles, which is 1.29 of them, to our, that's 1.29 moles, forgot my units. And you should also be putting units in here. That is pretty important. It makes sure it's a double check. It allows you to see if you have the correct units coming out. And it also allows you to have the correct units when you do your report, when you put your answer down. So there are 1.29 moles, and we are again on Mole Island and going to Mass Island. So when we do our boat, down below deck in the storage will be our 1 mole. Above deck in our area that we want everything easily accessible, because that's where, you know, all of our clothing and gear and games and all that stuff, activity stuff, for Mass Island goes up top. So that is 78.12 grams on the top deck, and then 1 mole stored down below of our boat here in storage. Again, our moles down below will cancel with these moles, and we will end up just taking 1.29 and multiplying by 78.12. The answer that I get for that is 100.77 grams. So there's 100.77 grams in 1.29 moles of C6H6 benzene. Interestingly enough, if I take this 100.77 grams and I divide it by 1.29 moles, you might wonder what we'd get, and it turns out we will get 78.12 grams per mole. So that's just where this molar mass comes from. If I take the mass and I take the number of moles that mass represents and I divide those two numbers like this, I will get my molar mass out every time, if we do it properly. Anyways, moving on, we have now the opposite direction. We are going from Mass Island, grams, to Mole Island. So we want to go in the opposite direction. And we are doing it for this magnesium chloride, MgCl2. So we need to calculate the molar mass of MgCl2. We can see that there is 1 magnesium, and that is 24.31 grams per mole, plus the molar mass of our chlorine times the number of chlorines. There are 2 chlorines, each one contributes 35.45 grams per mole. The answer I get when I plug this into my calculator is 95.21 grams per mole. Now I have my molar mass, and I can use it to go from Mass Island, grams, to Mole Island. So start off, we put our number of grams, and then I do my boat thing. And down below deck is my gram stuff. So that would be 94.21 grams. So every time you're going from Mass Island to Mole Island, you'll put this number, the molar mass number, down below. If you're going from mole island to mass island, then the mole number 95.21 would go up top. Anyways, we have our 95.21 on the bottom because we are going from mass island to mole island. On the top is the stuff we need for mole island, and that's 1 mole. And so this is basically taking 288 and dividing it by 95.21. The answer I get 3.02 moles of this MgCl2. All right, now we have 14.7 grams of H2S. So I need to find the molar mass of that. There are 2 hydrogens at 1.01 grams per mole each, plus sulfur. There's 1 of those, and it has a molar mass of 32.06 grams per mole. You might ask yourself, why was it last time, or why was it in the percent composition that I just wrote grams instead of grams per mole? There's a reason for that, because I'd said at the beginning of the percent composition video that we were going to assume that we had 1 mole of all the substances that we were taking the percent composition for. And so when I assume that I have 1 mole of something, let's say I had 1 mole of sulfur, that's like saying I'm taking 1 mole and multiplying it by 32.06 grams per mole. My moles cancel, and what I'm left with then is 32.06 grams. And that's why I was writing grams, and that's because we were assuming there was 1 mole of everything. Here we can't really assume that, and so we have to write out the full grams per mole. So I have this 2 times 1.01 grams per mole from hydrogen, 1 times 32.06 grams per mole from the sulfur, and the answer I get for that is about 34.08 grams per mole for H2S. 34.08 grams per mole, and that is our molar mass. In other words, I could write this as 34.08 grams divided by, or per, 1 mole. And whenever you hear something per something, it means division, and usually means division of 2 units. For instance, miles per hour is saying if you're going 65 miles per hour, you will go 65 miles in 1 hour. And then here, what we have is 34.08 grams per mole, or 34.08 grams means you will have 1 mole of that substance. Then to carry on, we are going from mass island. We have 14.7 grams, and we want to go to mole island. So 1 mole goes on top, and then on bottom we put our mass of 34.08 grams. My grams will cancel, and when I do this, it's basically taking 14.7, dividing it by 34.08. The answer I get is 0.43 moles of H2S. If I wanted to include the molecule, I could do that as well. What is the mass of 1.33 moles of copper 3 sulfite? So we have to realize that sulfite is SO3 minus 2. And we know that copper is 3 plus. So I write out my copper as copper plus 3. I write out my sulfite ion, SO3 minus. We do our crisscross, which says take the number up here on the sulfite and put it in the subscript of copper. And we also do the same thing. We take the 3 from the copper and we put it in the subscript of sulfite. And then my formula is Cu and then 2. And in parentheses, we put our polyatomics always in parentheses like this. And there are 3 of these sulfite molecules. And that happens because we get the 3 from the copper and bring it down to the sulfite. This is my formula for copper 3 sulfite. Now we have to find our molar mass. So that will be 2 times the mass of copper, because there are 2 copper atoms, and that is 63.55. Plus the contribution from sulfur. And again, sulfur, there's 1 sulfur in every sulfite molecule. But then there are 3 sulfite molecules. So this is kind of another one of those red ball, green ball type of problems, where if we had a sulfur, which is red balls, and we had a oxygen, which are green balls, then we have a cup that has 1 red ball and 3 green balls. So every cup has 1 red ball, 3 green balls. We have 3 total cups, which means that we will have 3 sulfurs. I'll put 3 times the mass of sulfur, 32.06. I'm forgetting units here. They are grams per mole. Grams per mole. We have to erase this here. And also, again, we have 3 green balls in each cup, and there are 3 cups, so we'll have 3 times 3 is 9 green balls or 9 oxygens, and we multiply each one of those 9 oxygens by that 16 grams per mole. So again, we have 63.55 grams per mole and that is from copper. There are 2 of them, so we multiply that together. We have 32.06 grams per mole. That is our sulfur's molar mass. There are 3 sulfurs in this entire Cu2SO33 molecule. So then we multiply the mass of sulfur by 3. And then there are 9, which is 3 times 3. 9 of these oxygens, and we multiply it by the mass of 16, molar mass of 16 grams per mole. When I do this multiplication, I get 367.2. That's my number, and I get grams per mole as my unit. We have 1.33 moles of this copper 2 sulfate or sulfite, and I want to convert to grams. So on the bottom, I put my stuff from Mole Island, right? We are starting at Mole Island, and we want to go to Mass Island. So I put my Mole Island stuff down below, which is 1 mole, down below deck and storage. And then above on my top deck, I put my Mass Island stuff, which is 367.28 grams. My moles will cancel, and what I get is this 367.28 times 1.33. And my answer is 488.48 grams. So there are 488.48 grams of copper 3 sulfite in 1.33 moles of copper 3 sulfite. And then mass. We want to know the mass of 7.94 moles of uranium 4 hydroxide. We are starting on Mole Island. We are going to Mass Island, and we need to figure out what our formula unit is. So our uranium is a +4 charged thing. And then we have these hydroxides, which remember we talked about. It's a polyatomic ion, and it has a charge of -1. So to balance our charges and make sure that we have a neutral molecule, I like to take my +4 and bring it down here to my hydroxide. So there will be 4 oxygens and 4 hydrogens. And then I will need to take my 1 from my hydroxide and bring it down here. And there will be 1 uranium and 4 hydroxides. So my formula is going to be, or my chemical formula will be U, only one of them, so just U. And then I open parentheses, I write in my hydroxide molecule, OH, and I know there are 4 of them. To calculate the molar mass from this, I have to take the number of uranium atoms, 1, and multiply it by the mass of the uranium atom, 238.03. That's grams per mole. I add my number of oxygens, which is 4 times 1, or 4. 4 oxygens times the mass, molar mass, 16 grams per mole. Plus another 4 times 1.01, again, that's grams per mole. I should write that in, but I'm running out of room there for the hydrogen. So we have 4 times 1 hydrogens, we have 4 times 1 oxygen, so 4 hydrogens, 4 oxygens. We multiply each of those number of atoms by their molar mass, and that's 4 times 16 for oxygen and 4 times 1.01 grams per mole for hydrogen. If we add all that stuff up, I will get 306.7, there's 306.07 grams per mole. And that is our molar mass for our uranium 4 hydroxide. Interesting thing about uranium oxides, uranium can do a lot of the same thing that silicon can do. And so if we have something like silicon that's bonded to oxygen 3 times, and each oxygen is bonded to a silicon, which is bonded to an oxygen, bonded to silicon, and this it makes this big long structures, and we call this stuff glass. That's not really what glass is to scientists, but it is called a glass. However, if we take one of these silicon out, or maybe more than one, several of them, every couple of them, and we replace them with a uranium, a +3 uranium, we get something called uranium gas or glass. There are other ways to make uranium glass, and it weird bonds and stuff that happen, but it's basically looks like glass. It looks like a marble or a bead or a glass pane or something. They're really cool, but when you shine UV light on them, they glow super, super bright green. It's really cool. Okay, so back to our discussion at hand here. Uranium, this uranium 4 hydroxide. Uranium 4 hydroxide has that molar mass that we calculated of 306.07 grams per mole. And then we need to figure out what the mass of it is given the 7.94 moles. So I write my 7.94 moles. I know my conversion, or sorry, my boat thing, and I am starting on Mole Island. So my stuff that goes below deck is my mole stuff, because we don't need it anymore. We're packing it away, and we're getting ready for a trip to Mass Island. On Mass Island, or to get to Mass Island, we'll take our boat, but we need to have all of our stuff ready for Mass Island, so it needs to be up deck or up on the top deck where we can reach it, and that is our 306.07 grams. My moles will cancel, and when I do this multiplication, I get 2,430 grams of this uranium 4 hydroxide. So 2,430 grams is 7.94 moles. And to check it, if we want to be sure, we can take 2,430 divided by 7.94. This is grams, moles, and the division should give us our molar mass back here. In fact, it does. 306. But we can round that up to 306.7. All right, one more. This is going to be kind of an interesting one. This is called ammonium permanganate. Both of these are polyatomic ions. So ammonium is NH4 plus 1. Permanganate is MnO4 minus 1. So if we do our crisscross thing, where we take our number from one thing and put it down in the subscript of the other, we'd have NH4 1 and then MnO4 1. So our formula for this molecule would just be NH4 MnO4. Each one of these ammoniums, these NH4s, has a +1 charge, and it will cancel out each one of the permanganates -1 charges. And so we only have one of these polyatomic, each of these polyatomic ions in our molecule. So to get the molar mass of this whole ammonium permanganate molecule, we'll have to look at how many nitrogens there are. It turns out that there's a total of 1, and that weighs 14.01, has a molar mass of 14.01 grams per mole. We have 4 hydrogens, so we take 4 times the molar mass of hydrogen, 1.01 grams per mole. We have 1 manganese, Mn, because Mg is magnesium. We have 1 manganese, and it is has a mass of 54.94 grams per mole. I'm saying mass, but I should say has a molar mass of 54.94 grams per mole to be more accurate. Finally, there are 4 oxygens. Each oxygen has a molar mass of 16 grams per mole. And if I do all this math here, all these multiplications and additions, the answer that I get out is 136.99 grams per mole. Now that we have our molar mass of our ammonium permanganate, we can take that and go from our mass island to mole island. We have 274.63 grams of this ammonium permanganate, and we want to go from mass island to mole island. That means our mass stuff goes down below deck where it's in storage, 136.99 grams. And on the top deck where we can get at it for our mole island adventure is our 1 mole. Our grams will cancel top and bottom, and then we are left with just 274.3 divided by 136.99. And that is pretty close to 2 moles. I think when I plug this in my calculator, I got 2.004, some other numbers, but we'll round it to 2 decimal places, and we will call it 2 moles. And that is the end of this video. So this was, again, our mass island to mole island conversion and back. We did some mass island stuff. We did mole island stuff. So we converted from grams to moles and from moles to grams. We also looked at different ways of expressing the molecule. So ammonium permanganate, and we had to find our formula for it using our balancing charges. And once we found our formula, we were able to calculate our molar mass. So in these problems that you'll see on the summative, they will come in 2 flavors. One, they will give you something like the formula, Na2SO4, and in the other form, you will get just that name with words like uranium 4 hydroxide. If you get the formula, say Na2SO4, you will be able to use that to go right away to grams per mole by figuring out the number of each atoms and multiplying that number of atom by its mass, its molar mass. And then you can use your molar mass to convert from moles to grams or from grams to moles. If you are given like a name, like copper 3 sulfate or sulfite, copper 3 sulfite, then you will have to figure out the formula first. Once you have the formula, then you figure out your molar mass. Once you have your molar mass, then you can convert from moles to grams or from grams to moles. So hope this helps you out. And let me know if there are any issues. And as always, good luck on that summative.